Okay, this video is about adding vectors graphically. And before we begin, a ball is thrown from shoulder level at approximately 1.65 meters above the ground to a height that's going to be 6 meters. What's going to be the total distance traveled when this ball lands on the ground, and what is its displacement? Well, the total distance traveled is going to be the length up and the length back down, totaling 10.35 meters. But the displacement, I start here and I end up in the negative 1.65 meters away. So the distance traveled is 10.35 meters. The displacement in the y direction is a negative 1.65 meters. And in this video, what we're going to do is we're going to add vectors graphically. And this is also known as the head-to-tail method of vector addition. What I'm going to ask that you do, though, is review pages 55 to 61 to help you along here. So let's get started. Okay, we're going to get some review here about vectors real quick. And equal vectors are the ones that have the same magnitude and they're going to point in the same direction. So here's a vector, and I'm going to draw another vector here. These two vectors are equal because they have the same magnitude and they're pointing in the same direction. So is this vector, and so is this vector. However, this vector here is going to be the negative of the first one because it's pointing in the opposite direction. Same magnitude, but in the opposite direction. Suppose I want to get from point A to point B on this map here. So I have a couple of choices. I can go up, I can go over, and then up again, or I can go up here, and then over here, and then up here, or I can go any variation of those. And so what I can do, I can start by going up, and then over, and then up, and then the resultant is getting from point A to point B is simply adding all three of those together, and that's this red line here. Well, this new red line has its own magnitude and its own direction based on the drawing here. So I can start with vector A here and go straight up, go over with vector B, and then straight up with vector C, and if I add all three of these together, I'm going to get a resultant. The resultant is called R, and the R is just simply the result of adding all of these vectors again or together. I can change the order in which I add my vectors. If I start with B and go over, and then go up with A and then up with C, my resultant is going to be exactly the same number just as before. Or I can change up the order even more and say I start with C, and then B, and then A. Either way, I'm going to get the same vector. And how we're going to add these vectors together is notice that every vector has a head and a tail. A head is where the arrow is pointing, the tail is the end of it. To add vectors, I simply take and draw my first vector. I place the tail of the second vector to the head of the first one here. And then I place the tail of the next vector to the head of the other one. This is called the head-to-tail method of vector addition. Okay? All right, let's try this head-to-tail business. So here's I've got some vectors here, and I want to add A to G. Well, if I find A here, I find that it's 1, 2, 3, 4 units long, and it's pointing in that direction. G, on the other hand, is 1, 2, 3, 4, 5, 6, 7, 8 units long, and it's pointing along the same direction. So if I start with A, and I place the tail of G to the head of A here, and I just simply add these two together, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units. I started here, I ended up there, so now I can describe this resultant as being 12 units to the right, or 12 units to the east, or 12 units at 0 degrees from the horizontal. Each one of these designations is the same in describing this resultant vector. Let's go ahead and subtract the second one to the first. Well, A, I've done nothing to it, so I'm not going to change it. But G, because it's a negative G, I'm going to take the same magnitude and point it in the opposite direction here. And if I started here and I ended up here, the resultant is going to be the result of these two of 1, 2, 3, 4 units, this time to the left, or 4 units to the west, or 180 degrees from where I started. I started here, 180 degrees later, I went in that direction. Now, if we multiply our vectors by a scalar, well, I've got A here, and if I multiply it by 2, that just simply means I have twice as many units as I did before. So instead of 1, 2, 3, 4 units for A, it is now going to be 8. I start with 2A, and I add G. I add them as just like I did before, and I get 16 units to the right and 16 units to the east, or 16 units at 0 degrees from the horizontal. Now let's go ahead and try a little bit different one. Here I've got G, which is this many units this way, but notice H is going to be going up, but the same rules are still going to apply. I'm going to go ahead and start with G here, and I'm going to place the tail of H to the head of the first one. And when I do that, I'm going to get a resultant that starts here and ends up over here. Now, with adding vectors graphically, I can just simply get out my ruler and measure the distance between these two, and that's going to give me the magnitude of my resultant. And I can get my protractor out and measure the angle between these two, and that's going to be my direction. And I can do that graphically, or I can use my trig ratios, which we're going to do next, to get the answer. But I'm going to go ahead and choose to get out a ruler and a protractor and measure the resultant here to be approximately 10 units at 36.9 degrees north of east, meaning that's this angle here. Or I can say that it's 36.9 degrees from the horizontal. Again, either way, I can measure this graphically, or I can use my Pythagorean theorem to get my hypotenuse and my trig ratios to get the angle. I'm still going to get the same answer whether I do it graphically or mathematically. Okay, so in this video, what we did is we added vectors graphically using what's called the head-to-tail method. Tomorrow or later on in the week, we're going to add these vectors mathematically, and we're going to know a little bit more about trig to do so.